Hey, good morning, everybody. This is Mr. Aynesworth here at Great Oak High School in Financial Algebra, and we're going to get into a little review over sections 4, 5, 6, and 7 in Chapter 9, talking about the expense, revenue, and profit functions all together. So get your Desmo set up here. Notice that I'm split screen. I have it on the right. So go ahead and log into your account and save your work. So put a good title in here like we always do. Just use the same title as the lesson. All right, so sections 4, 5, 6, and 7, and then review of the functions. Review of the expense, all right, revenue, all right, and profit functions. And so what we're going to do is we're just going to get right into it here. We're going to use Desmos to help us calculate all the key things, and we're going to use Desmos to do the graphing, and we'll sketch the graph here in our project, and we're going to label it, annotate it, and interpret it and what's going on. So let's get right into it. Part 1, here we go. Lindemann Industries manufactures makeup products. A particular item in the product line costs $2.25 each to manufacture. Okay, right there we have the unit cost. Okay, so we know that the unit cost of the product is $2.25. All right, per item in their product line. So per item, that's unit cost. All right, the fixed costs are $3,000. So right there, I can write the expense function in terms of Q, okay, in terms of the demand. Okay, and we want to write it in terms of P, but we got to write it in terms of Q first, where Q is the quantity of the public demands at a particular price P. They also give you a demand function, okay? So we know the demand function, Q in terms of P. We're given the fixed costs and the unit costs, so we can write the expense function first. So we're going to use E for expense function here, and that's going to be equal to the variable costs plus the fixed costs, as you guys already know. Again, this is just review. This is going all the way back to section 4. All right, and so the expenses are always equal to the variable cost, which is you take the unit cost times the quantity. So we're going to take $2.25 times our quantity plus the fixed costs, and we're given that the fixed costs are $3,000. Okay, now we can't graph this on this graph right here, because on the graph we have price on the horizontal. Okay, well, there's a price on the horizontal, and we're going to have revenue, or we're going to have the expense, or we're going to have the profit in terms of dollars on the vertical, depending on what three functions we're looking at. Okay, so the price is on the horizontal, and all three of these, the revenue, the expense, and the profit, depend on the price. And that means we need all functions in terms of P, not in terms of Q. So we can't graph this on the coordinate plane here, because it's in terms of Q and not P. So that's why the directions say write the expense function in terms of P. Well, to do that, you got to take your demand function, which is right up here, and you got to substitute that in. Okay, this is a skill we've been developing throughout all the lessons here. And we know that Q is equal to negative 1,000 P plus 6,000. Okay. There we go. So let's substitute that in. So we have the expense function here is $2.25 times our demand function, which is negative 1,000 P plus 6,600. Okay, that's 6,600, not 6,000, so keep that in mind. All right, plus 3,000 more. All right, so what is this? Well, we've got 2.25 times negative 1,000, so it's negative, first of all. And when you multiply a number by 1,000, you just shift the decimal place 3 places right. That's something that you guys should know. Or use Desmos if you can't figure that out. And then here I've got to distribute to the 6,600. So I'm going to take 2.25, so let's go to Desmos now. All right, 2.25 times the 6,600. All right, then I have to add the 3,000 here. So might as well just do it all in one. And you got to type this in correctly. So notice that I didn't type my unit costing correctly, so always double check your work. My answer was in the millions, and so I knew I made a mistake typing it in. You got to take your unit cost, which is $2.25, times 6,600 plus 3,000 more, and you get 17,854 as part of the expense function. So plus 17,850. All right. And I have my expense function in terms of P. That's what it means in terms of P. And now I can graph that function. I'm going to graph that down here in a minute in Desmos. We'll do that. Okay, now let's get the revenue function now. The revenue function in general, okay, R for revenue, capital R for revenue, is price times quantity. So price times quantity. Okay, and so R is equal to P times Q. Now we know what Q is. It's our demand function. So I need to substitute that in again. Okay, so we're going to make two substitutions. So the revenue is equal to P times negative 1,000, P plus 6,600. Distribute through the P, because you got to distribute not once but twice. Okay, and you get negative 1,000 P squared. There's your quadratic, plus 6,600 P. Okay, now this is a, we're going to graph this, okay? So we're going to do that down here. We're going to do this in decimals here. And notice that's in terms of the price. And so now what we need to do is get profit in terms of the price. Okay, now profit, as we talked about in section 7. Okay, so this is section 9.7 here. The main concept for profit, capital P for profit. Okay, so let's just make it simple here. So capital P for profit is equal to the revenue, all right, minus your expense. Revenue minus expense. Okay, so profit, capital P. Okay, little p is price, capital P is profit. Just keep that in mind. All right, you've got to take the two functions and subtract them. So let's do that. Okay, so my function profit is going to be taking my revenue function, which is right here. It's step 2. Right, negative 1,000 P squared plus 6,600 P, and I have to subtract. All right, subtract the entire expense function, which is negative 2,250 P plus the 17,850. Now make sure you use parentheses here, because when you subtract a function, you have to distribute through the minus sign. Okay, the most common mistake people make is that they don't do this and they get the incorrect result. Okay, so you have to distribute through. So here we go. So negative 1,000 P squared plus 6,600 P, and then there's a double negative there, so plus 2,250 P, and then minus 17,500. Okay, we got to collect like terms. So profit function equals negative 1,000 P squared. Okay, plus, let's see here, 6,600 plus 2,200 is 8,850 more. So 8,850 P. All right, minus this constant here, 17,500. And that, my friends, is your profit function. And we're going to graph that too as well. Okay, we're going to graph all three, all right, on the same axes. Okay, we can do that because it's in terms of P, the price. That's why we had to make all these substitutions. Okay, so my first function is the expense function in terms of the price. My second function that I found was my revenue function in terms of the price. And then my third function I found, I didn't find it, I developed it, I derived it, okay, is the profit function. Okay, so I've got the profit function in green, I've got my revenue function in blue, and I've got my expense function in yellow. And we want to graph all these three functions on the same axis. Okay, we're going to use decimals to do that, and then interpret all and answer all these questions right here. Okay, so the first thing we need to do is get this side by side with decimals. Okay, so here we go. So I'm going to start entering the functions in, and I'm going to do a variable switch. So instead of E, R, and P, it's going to be Y. Okay, and then instead of price, I'm going to have X, because the price is on the horizontal axis, which is typically the X-axis. So either X or P would work. Okay, so here we go. So first expense function, Y equals, all right, negative 2,250P, but I'm going to type in X here because it's the X-axis. All right, plus 17,850. So plus 17,000. Okay, there's my expense function. And make sure you check your functions as you type this in. So I'm checking right now. I think that's good. Okay, next one, the revenue function. So Y equals negative 1,000, all right, X squared. Okay, you can use your digital keyboard, or you can type it in on your keyboard on your computer. All right, plus 6,600. Okay, x right here, that's obviously not typed in correctly. So let me fix that. So plus 6600x, and there's your parabola right there. All right, and now my profit function. And so that's going to be y is equal to, all right, negative 1000, all right, p squared, or x squared, plus 8850x, so plus 8850x, minus that big constant, 17,500. Okay, so now click on save your functions, and let's take a look at the graph of these functions and then answer all our questions right here. So I'm going to expand this, and this is going to happen to you here. Notice that we don't see a parabola, two parabolas here. We should have two parabolas on a line. The expense function is linear, and the revenue and the profit functions are quadratic. So we're going to have to adjust our x-axis. So we're going to go from 0 to, now I really don't know what the x maximum should be, so I'm going to start off with maybe 20, see if I can see that. That might be good. If 20 is not big enough, I'll increase it to 50 or 100. You know, each problem is different, so you'll have to adjust. And the y-axis, what you want to do is you're going to look at your expense function up here, and the y-intercept is 17,850. So on the y-axis, I have to go up to maybe up to 20,000 in order to see where the line hits the y-axis. A little bit something greater than 17,850. So I'm going to just make it simple, and I'm going to type in 20,000. And notice that I can see everything, okay? So I'm going to expand this out so we can see a little bit better. So really our x-axis could have been adjusted from 0 to 10, because notice that everything happens before x equals 10. So I could have adjusted from 0 here to 10. So I'm going to do that just to go over the scaling, because it's so important. You're not going to be able to see your graph unless you scale it properly. See right there, see? And then I can go from 0 to 20,000 on the y-axis, and now I can see everything. So the expense function is in blue, and the revenue function is in green, and then the profit function is in purple. So let me see. There we go. So click on save, and I'm going to highlight all the critical points. So where the expense function meets the y-axis is called the y-intercept. Okay. Where it meets the revenue curve, we got 2 break-even points right there. Now the top of the revenue curve gives you the maximum revenue. So we could, let me see here. What's going on here? Okay, there we go. So why is it? Come on. I only want things to appear once. I don't know why that was appearing twice. Okay, so just click on all the critical points here. Click on your break-even points. Click on your roots of the quadratic, which is where they intersect the x-axis. Okay, we have 2 roots there. And then the roots of the profit function, the vertex of the profit function. And let's see. There was a mistake somewhere. Let me see what happened here. Let me pause the video. I gotta figure out what happened. Okay, I figured out what happened here. On my profit function, it's not 17,500. It's 17,850. So I entered the wrong function in, and that's why I knew I was getting some incorrect results, and I'll talk about that here in a minute. So you got to enter the right function in, okay? It should be minus 17,850. Okay, so now let me click on all my critical points here. So the y-intercept up here, the first break-even point on the, here we go again. So let me start over here on these functions. So there we go. So that's the max revenue right there. Break-even point on the left, other break-even point, my y-intercept, my roots are the x-intercepts. And then I've got other roots of the profit function in purple. Okay, now these are the correct values. Okay, and I'll explain why here in a minute. Okay, So now I have all my maximums, I have my break-even points, I have my roots, and I have my x and y intercepts. I have everything. So now what we want to do is interpret. Okay, so here we go. So let me clip this in. Excuse me, give me a second here. Using technology here. Okay, so let me bring this into the lesson. Bear with me here. Okay. Now, of course, you're going to sketch the graph, okay? And unless you're digital like I am, you can do what I do. But you go ahead and sketch the graph right there, and now let's go ahead and annotate the graph and figure out what's going on, okay? Here we go. This is why I love Desmos, is because they give you all the information. It's very simple, and then all you have to do is learn how to interpret it. So question, the first part here. So the price that yields the maximum revenue, okay? So right here, if you go to your graph here, in fact, you know what, let's label the graph so you know which is which. Okay, so this is your expense function. Okay, the green one, okay, is your revenue function. And then the other one, the purple one, all right, is your profit function. Okay, profit. All right, so now let's annotate. Okay, so remember, this is price is on the x-axis. It's always price there, and then on the vertical axis we have what's called the revenue, or the expense, or the profit, depending on what function we're looking at, because there's three functions on the same graph. So this represents, you know, one of the three. All right, now let's start off with the expense function. Okay, so the expense function here, this is your expense function, in blue, all right, has a y-intercept. Okay, so this is called a y-intercept. All right, and this is called a slope. All right, and notice that the y-intercept of 17,850 matches Desmos. Okay, there we go. So, and then the slope is negative 2250. So we're looking good there. Now, the revenue. Okay, the revenue function here. This is a revenue function, and then in purple is your profit function. All right, so let's talk about the revenue function. The max revenue occurs at the vertex. So we've got a price here, and then we have a revenue. It's always price and then revenue. So what this tells me is that if P is $3.30 right here, all right, we have a maximum revenue. Okay, it says right here, $10,890 bucks. So $10,890, and of course bring that up here. Okay, so $3.30 max revenue, $10,890 bucks. Always put dollar signs and commas and decimal points in your currencies. Okay. So now, let's see here. Okay, so now what is the price that yields maximum profit? Okay. Okay, so to answer that question, we talked about how maximum profit occurs at the greatest distance between the revenue and the expense function. And so I'm talking about the distance between the two functions, and the only place where the function's profit, or excuse me, where the company profits, is between the break-even points. And so I should have done that in Desmos. Let me see. Let me go back to Desmos real quick. I forgot to do that. So I'll tell you what, let's take a look at the first interval between 0 and your first break-even price, which is $3.11. Looks like 11 cents. We can figure out if the company's profiting or losing money right there just simply by picking a price. So let's pick a price of 1. I'm going to type in x equals 1 here. All right, and notice right here, if you, let me actually go, break-even price is $3.11. Okay, so let me put this in. So let's go for between 0 and $3.11. All right, watch this, is kind of cool. So there's a little slider here, and you can figure out the profits, whether the company's profiting, just by looking at the expense and the revenue. So at 90 cents here, because the first quarter is 90 cents here, the expenses are $15,825, where the revenue is only $5,130. So between the first break-even point and 0, in this first interval here, the company's losing money. Okay, now between this, the middle interval, between the first break-even point and the second break-even point, between these two values, so between $3.11 and $5.74. Okay, so let's type in, let's pick a value in there like 4. Okay, so x equals 4, and whoops, x equals 4, and we're going to type in the break-even prices here. So $3.11 to the other one, which was $5.74. So $5.74. Put a step of 10 cents here. Watch what happens. You can a little slider here, and you can see in between the break-even points here, the difference between the revenue and the expenses is kind of small right here, so the profit's not very big, but as you move to the right, it gets bigger and bigger, this difference. So between these two curves right here, you can see that it gets bigger and bigger, and then if you slide to the right and get closer to the other break-even point, all right, the profit decreases right here. The distance between the curves is a profit that decreases. So where is it biggest? Well, it's got to be biggest somewhere right in through here. Okay, somewhere in there. And if you look at the purple curve, excuse me, which is your profit curve, okay, profit always occurs at a maximum, which means it occurs at the vertex. Okay, so it occurs right around here. So somewhere between $4 and $4.50 is going to be the maximum. So if you click on it right here, you click on the revenue curve, and you click on its maximum, the maximum occurs when the price is $4.43. So if I type in x equals $4.33, $4.33, you'll notice right there that I have a max there. Okay, so what happened here? Oh, 43 cents, not 33 cents, 43 cents. So let me gotta check that here. Change that to 43. There we go. So we got a maximum at $4.43 if the price is set there, and then a maximum profit occurs when the price is set that, and the profit equals $1,730.60, and it occurs between these 2 points right here. So the profit, if you take the revenue, which is $9,613.10, and subtract $78.8250, all right, you're going to get a profit of $1,730.60. Okay, and that occurs if you're at the vertex of your profit function, all right, which always is located between the break-even points. All right, so I'm going to click on all the critical values again here. So between these two break-even points, we can find the maximum profit where it occurs. And it occurs if the price is $4.43. All right, so let's go back to our lesson here and annotate. All right, so this is our max profit here. So there's your price. So this is the price, and this is your max profit. If you draw a vertical line straight up. So if you take the revenue here and you subtract the expense, all right, you get the profit. Okay, so and it always occurs in this middle region here between the break-even points, always. Okay, and it occurs at the maximum or the vertex of the profit function. Okay, so let's record that. Okay, so the maximum profit price, let's see, was $4.43. $4.43. Profit $1,700, excuse me, $30.63. Just look at the vertex here. Okay, of the profit function. All right, where the price and revenues at the break-even points. Okay, so this is P1, and this is P2, and this is a break-even point. Okay, so this is B2, and this is B1, break-even point 1. Let's call it BE1, actually. Okay, so break-even point 1, and then break-even point 2. So break-even point 2. All right, so let's put those prices in. So $3.10, no, 11 cents, excuse me. And then the other one was $5.74. All right, the roots of the function, R1 is here, R1 is 0. We're talking about of the revenue function here, so the curve. And then so here's R2, R2 is 660. So $0, and then 660 here for the second one. And then, all right, let's talk about the intervals where the company profits, okay, and or loses money. So we want to find the profit interval. So the profit interval is always between, all right, the two break-even prices. So let's highlight that. So just go straight down. Oh, right here. Okay. And so, okay, so notice the break-even prices occur where the profit function meets the x-axis. And that's important because the break-even points, that's where revenue, okay, revenue equals expenses, okay? Now, if revenue equals expenses at the break-even point, this is a main concept right here, okay, that means that profit equals 0. Profit equals 0, and that means loss equals 0. Okay, you don't profit, you don't loss. And right here, this is where profit equals 0. P equals 0. Profit equals 0. Profit equals 0. And right here, at the other one, that's where P equals 0 as well. I mean, just look at it. Right here. P, capital P now, not little p, but capital P. Profit equals 0. You can see it in the point, and you also see it on the graph right here. And so wherever the break-even price is, if you go straight down, that's where your profit curve should meet. Because at the break-even point, there's 0 profit. So your profit function has to hit the x-axis, or the price axis in this case, at the same position, so at $3.11. Notice these are the same. So let me highlight these. So $3.11, $3.11, and then $5.74, and then $5.74. They should match. Okay, so let's analyze a little bit more and talk about the intervals where the company is profiting versus losing. So between the break-even points is with the profit interval. So between $3.11, and the other one, the break-even price, $5.74. In through here, this middle interval, which I'm going to call I2, is your profit interval. Okay, profit interval. And the way you represent that is by taking your break-even price, okay, which is $3.11, all right, and say, hey, if that's less than the price, which is less than the other break-even price, which is $5.74, the company profits. Okay, so if the price is between those two numbers, the company profits. If it's to the left, okay, between 0, okay, in the first interval here, between 0 and $3.11, the company loses money. So loses money here. There's a loss right through here because the expenses, all right, are greater than the revenue. And if you're to the right of the break-even point, okay, in the third interval, okay, if the price is greater than the $5.74, then the price is too high, as we were talking about right here, and the company loses money. Okay, and that's because, again, the expenses are greater than the revenue because the price is too high. Price is too high. Okay, the demand will decrease at that point, go to 0, and if that's the case, the company won't sell anything, won't make anything, and they'll start losing money. And that, my friends, is the last part here. It says, what are the intervals in respect to the price where the company profits or loses money? Well, there you go. All right, and that, my friends, is the first problem. So now what we need to do is take a look at part 2. Actually, before that, we gotta answer all these questions here too. So this is actually a summary of what we just talked about. So this is using the graph that we just produced. So the price at the first break-even point we said was $3.11. At the second break-even point, $5.74. State the interval between the two break-even points. I just talked about that right here. So $3.11 is less than the price, less than $5.74. What would the revenue be at $4? Okay, let's use decimals for that. So let's go back here and let this be 4. So let's see. So here we go. There's your revenue and there's your expense. There we go. And notice that revenue is greater than expense. So on this one here, let's write these two numbers in here. So at $4, the revenue is $10,000. So $10,400. All right. The expense, if you look at the graph here, so $88.50. All right, there. So revenue is greater than expense. That's a good thing. Okay, and the company's profiting in this case. And the way you figure out your profit, as you guys know, profit equals 10,400 minus the 88.50. And if you just type that in, we got 10,400. All right, minus 8,500. Oops. All right, and notice that the profit right there is 1,900 bucks. Okay, so that means they're making that much money. Okay, and there you go. There's a wrap on part 1 here of the problem, and that's how we interpret everything given all 3 functions from the situation. So now what we need to do is take a look at part 2, and we'll continue that in a momento.